After the video capturing is done, we have a series of video clips recorded on the computer disk. We'll process these videos to create one photo of Jupiter per video. If we want to make a derotated photo, we will need a continuous series of 5 to 10 videos taken at the time of the best seeing, at an interval of 10 to 20 minutes. I select the best quality videos by playing and viewing them in the SER Player program. In this example, I have already selected 7 consecutive videos taken in a period of good seeing, at an interval of 15 minutes, from 23:55 Universal Time to 0:10 Universal Time. As already mentioned, we want to get one photo from each video by stacking, or integrating, all the frames of that video. For this purpose, I use the Autostakkert 4 program. Since I have to process 7 videos in the same way, I will use a very good feature of this program that allows for batch processing of multiple videos. With the Open command, we first select the videos we want to process. The selected videos are marked with an X in the last column. Then we check the Clear/Reset on File Open box, which is important because this option allows us to set alignment points separately for each individual video. We start the processing by clicking the Close and Process Data button. First, we set the most important video analysis setting parameters in the left part of the window and start the analysis of the first video by clicking the Analyze button. The goal of the analysis is to sort all the frames from the video by quality and select the best one, which is the one we see in this window on the right. Next, we set the alignment points. Before that, let's check if the brightness is set to 1x, which means the original appearance of the recorded video. It is best to leave the scaling parameter on auto. To see the details on the planet's disk better, we increase the zoom, for example to 150%. Then we adjust the size of the field around the alignment points, AP size, which determines their distance from each other and the total number. I usually use a size between 48 and 80, depending on the quality of the recorded details. In this example, I would choose a size of 64. The last important parameter is min bright, which is the threshold of the required brightness of each of the alignment points. A threshold that is too low will also take into account points outside the planet's disk. I usually take a value between 15 and 30, here it will be 25. From my experience, I recommend enabling the Replace and Multi-Scale checkboxes and leaving Close to Edge empty. By clicking on Place AP Grid, we start placing alignment points on the best frame of the planet disk, which is marked with a quality of 100%. The displayed curve shows the quality distribution of all video frames, which will help us choose the optimal percentage of the best frames for stacking them. The first one on the left is the highest quality, and the one on the right is the lowest. By clicking on some part of the curve, we select a specific frame in that sequence and we can see how much its quality is compared to the best frame. By moving this point, I can see what percentage of frames have a quality higher than 60%, because I only want to use such frames to create a stacked image. In this case, it is about 15%. Before stacking, I enter this percentage, or more of them, in the Frames Percentage to Stack boxes and select the best frame again by placing an index line on the left edge of the curve. Before starting the stacking process, we should check the image format settings, TIFF, normalization, RGB alignment, and leave the drizzle option turned off. Finally, we start the alignment and stacking process by clicking the Stack button. In this process, the program will analyze, set alignment points, and align and stack all the best frames of the video at the selected quality percentage. When it is finished with the first video, a subfolder labeled AS_P15 will appear in the source folder, where the stacked images of each individual video will be stored. After processing this first video, all other selected videos will be processed in the same way and with the same parameters. That is why this process will take a while, and in my case it will be about 12 minutes. The process will take longer if the videos contain more frames or if we select more alignment points, and many times longer if we turn on the drizzle option. The processing power of the computer also plays a big role. I use a laptop with a 13th Gen Intel Core i5-1335U processor and 16GB DDR5 5200 MHz RAM. After this processing is complete, the original video folder will contain a subfolder labeled AS_P15 with all the images stacked from individual video clips. We can open the folder and view the stacked images. In the next part of the tutorial, we will see how to sharpen them with the Registax program and prepare them for derotation.